Could life have been brought to our planet from space? Is it possible for living forms to be transferred from Mars to Earth? And could bacteria survive such a journey? Or were only the building blocks of life transferred from space to Earth? We will try to answer these and similar questions in today's episode of the series Secrets of Genes, in which I welcome you. My name is Eduard Kejnovsky, and I work as a geneticist at the Academy of Sciences of the Czech Republic. In previous chapters, we mentioned that the problem with Miller's scenario, which placed the origin of life on the Earth's surface, is the presence of oxygen in the atmosphere. However, even the hypothesis of life originating at the bottom of the ocean is not without flaws. Its weakness is the high temperature. It is generally assumed that the first genetic systems, that is, systems capable of making copies of themselves, were nucleic acids. Specifically, one type of nucleic acid called RNA or ribonucleic acid. And it is known that RNA does not tolerate high temperatures well, as it easily breaks down under such conditions. And only later in evolution was it replaced by the well-known molecule DNA, deoxyribonucleic acid, which still serves as the medium for storing genetic information today. It is therefore clear that RNA molecules would not survive long near hot hydrothermal vents. To avoid the problem of the instability of the first replicators at high temperatures, as well as the destructive effects of oxygen, scientists came up with a new scenario. They placed the origin of life in shallow lagoons on the Earth's surface. There, among other things, was also an abundance of nutrients, which were washed in by the rain. In addition, the solution in the lagoons was concentrated by the evaporation of water, or even by its repeated freezing. The first molecules of life were also protected here by a layer of water from ultraviolet radiation. However, the organic substances from which the first genetic systems arose could have reached the lagoons in other ways as well. From space. Space is in fact rich in organic substances. Enormous amounts of polycyclic aromatic hydrocarbons have been discovered inside some stars. And we don't even have to look that far. Even Halley's Comet contains about 25% organic molecules. Astronomers have calculated that hundreds of tons of meteorites fall onto the Earth's surface every day, many of which also contain organic substances. And in the past, when the Earth was not protected by the shield of the atmosphere, in which most meteors burn up today, the bombardment of Earth was apparently even much more intense. So there was probably enough material necessary for the formation of the most primitive forms of life. The discovery of organic substances in cosmic dust, meteorites, or comets clearly demonstrates that if fully formed life did not arrive on Earth directly, then at least its building blocks did. In 1969, a remarkable event took place in Australia. Near the town of Murchison, north of Melbourne, meteorites fell. To be more precise, it was a heavy meteorite shower. Some of them weighed several kilograms. It was a rare type of meteorite, a so-called carbonaceous chondrite, 4.5 billion years old. But what was most interesting was that inside its cavities, the so-called chondrules, it contained amino acids, the building blocks of proteins. And not just any amino acids. There were 72 in total, but only 8 of them are used to build terrestrial proteins. There was another interesting thing as well. Amino acids actually occur in two forms, left-handed and right-handed. It's similar to how snail shells spiral either to the left or to the right. And in terrestrial proteins, only left-handed amino acids are used. However, meteorites contained a mixture of both types, although the left-handed forms predominated. Today, scientists are asking why only certain amino acids were used in the formation of the first proteins. And why did life favor the left-handed variants? What if more complex forms of life, such as bacteria, had already arrived on Earth? This idea is nothing new. To ancient philosophers, the creation of life from inanimate matter seemed so magical that they came up with the notion that fully formed life had already arrived on Earth from somewhere else, from another world. Already the Greek philosopher Anaxagoras, about 2,500 years ago, claimed that life, like the universe, is eternal and spreads through the cosmos from place to place. This idea, known as Panspermia, has been advocated in modern times by a number of leading scholars, such as the British scientist Lord Kelvin. Are you worried that living organisms wouldn't survive the long journey through space? It seems the opposite is true. There are many bacteria that are highly resistant to the extreme conditions prevailing in interplanetary space. These are the extremophils mentioned earlier. For example, the bacterium Deinococcus radiodurans is such an extremist. It is capable of surviving directly inside nuclear reactors, and it appears to be unaffected even by radiation doses of 15,000 grays, that is, doses 1,500 times higher than those that would kill a human. An ancient story could also be told by Bacillus sphaericus bacteria, which came back to life after being isolated from the digestive tract of now extinct insects that were encased in amber 30 million years ago. Most often, discussions focus on the possible transfer of life from Mars. It seems that, in principle, nothing stands in the way of an interplanetary express from Mars. Fragments of rock originating from Mars have been found that were not subjected to high temperatures or pressures during their ejection from the surface of the red planet, nor did they burn up afterwards during their passage through Earth's atmosphere. It has been found that even a thin layer of rock is capable of protecting potential life from ultraviolet radiation during its journey through space. When large bodies such as comets or asteroids impact Mars, rocks are ejected from its surface, and a tiny fraction of them may, sooner or later, cross Earth's orbit. It has been calculated that most of them will hit Earth after tens of millions of years, but 1 in 10 million objects can travel from Mars to Earth in less than a year. And that's a short enough time for bacteria to survive certain hardships. The most daring idea came from Nobel Prize winner Francis Crick, who discovered the structure of DNA. He believes that panspermia could even have been directed. According to him, intelligent beings from another planet could have sent a spaceship full of microbes to Earth 4 billion years ago. Does that seem impossible to you? After all, even today, scientists are considering the colonization of other planets. However, it's likely that if someone less prominent than a Nobel Prize winner had come up with a similar idea, they would probably have been ridiculed. So that's all for today. In the next episode, we'll talk about the oldest forms of life found on our planet. We'll talk about the so-called stromatolites. I'm looking forward to seeing you. If you enjoy my storytelling, I'd appreciate a like. And if you'd like me to continue making episodes about genetics and evolution, please subscribe, which will help these videos reach more people. I really appreciate your support. Thank you and bye-bye.